Beckett sends one man for the foreman. The other helps him check the obvious things first, because there has to be an explanation. There's always an explanation. They start with the feed line, the main pipe that normally brings water from the reservoir into the boiler. The connection is open, dismantled, the gasket sitting on the floor where the day crew left it. No water flowing, no water possible. The main shut-off valve, cast iron with a hand wheel the size of a dinner plate. Beckett tests it, closed, sealed. The packing gland is tight, no drips, no seepage. He puts his weight into the wheel. It doesn't budge, hasn't moved in hours. They check the blowdown valve at the bottom of the boiler, the drain used to empty the vessel. It's not just closed, it's chained, padlocked. The key hangs on a nail 15 feet away. The foreman arrives, a man named Garrick who's been with the mill since the turbines were installed. He listens to Beckett's report with his arms crossed, jaw tight. He doesn't interrupt. When Beckett finishes, Garrick walks to the sight glass himself and stares at the water level for a long time. "Check the condensate return," he says finally. They do. The return line, meant to bring condensed steam back from the system, is capped. Solid iron cap, threaded tight, painted over, hasn't been removed in months. Garrick tests every valve himself, every union, every pipe junction. His hands move with the practiced efficiency of 30 years in steam. The other workers watch in silence, holding lanterns high. Nothing, every line is isolated, every valve is closed. There is no path for water to enter the boiler. And yet, Beckett checks the sight glass again. The level has risen. Not by much, maybe an inch, but it's higher than it was 20 minutes ago. One of the younger men, a kid named Porter, takes a step backward. "It's filling itself," he says quietly. Garrick snaps at him to shut his mouth, but the words hang in the cold air like smoke. They all heard it. They all saw the level rise. The boiler house is silent, except for the distant hum of the operating boilers in the next room and the slow drip of condensation from the overhead pipes. Somewhere in the darkness, metal contracts with a soft tick as it cools. Beckett presses his palm against the sight glass. The water inside is cold. He can feel it through the thick glass. Cold water in an isolated boiler with no source, no inlet, no possible explanation. Rising. By morning, the whole mill knows. The day shift crowds into the boiler house before their rounds, wanting to see it for themselves. Garrick tries to keep them out, but word travels faster than orders. They stand in clusters, pointing at the sight glass, touching the cold metal, testing the valves like they don't trust the night crew's report. By noon, arguments break out. Mitchell, one of the senior mechanics, insists it's sabotage. Someone's playing games, sneaking water in through a hidden line, trying to make the night crew look like fools. He demands a full inspection of every pipe in the building, threatens to tear out walls if he has to. Garrick accuses the night shift of missing something obvious, of not checking thoroughly enough. Beckett takes the accusation like a slap but doesn't respond. He just points at the sight glass. The water level is higher than it was 8 hours ago. No one can explain it. A reporter from the town newspaper gets wind of the story by evening, probably from one of the day labourers who drinks at the tavern near the rail yard. The article runs 2 days later, a half column on page 4 with a mocking headline. Mill's mystery boiler fills itself, engineers baffled. The article treats it like a joke. It quotes an unnamed source saying the night crew probably left a valve open and won't admit it. It speculates about the strange properties of steam and phenomena not yet understood by modern science. The workers don't find it funny. Porter refuses to enter the boiler house alone after dark. He's not the only one. The night crew starts working in pairs, keeping lanterns lit even in sections they're not using, glancing over their shoulders at boiler number 3 like it might do something worse than fill with water. Beckett finds himself checking the sight glass every time he passes, even when he's not assigned to that section. The level keeps rising, slowly, irregularly, but always rising. Some days it gains 2 inches, Other days, nothing. There's no pattern, no predictability. Mitchell tears apart the feed line, convinced there's a hidden valve or a crack in the pipe allowing water to seep in. He finds nothing. The pipe is sound, the joints are dry, the fittings are tight. Someone suggests calling in an outside engineer, someone from the city with experience in unusual mechanical failures. Garrick refuses. He's not about to admit to management that his crew can't solve a simple water leak. Besides, there is no leak. That's the problem. The older workers, men who have spent decades around steam, start telling stories about a boiler in Pennsylvania that exploded for no reason, killing 8 men. About a pump in Ohio that ran backward one winter, draining a reservoir in 6 hours. About machines that sometimes do things machines aren't supposed to do. Nobody says the word haunted. They don't have to. The boiler sits in the darkness, cold and silent, slowly filling with water that has no source. What's happening inside boiler number 3 isn't supernatural. It's physics, brutal, elegant, and unforgiving. Here's what nobody realized during those first 3 days. A cooling boiler doesn't just sit quietly in the dark. It becomes something else, something active. When the fire goes out and the steam inside begins to condense back into water, the pressure drops. Not just a little, dramatically. Steam at atmospheric pressure occupies 1,600 times the volume of the water it came from. When it condenses, all that volume collapses. The result is vacuum, negative pressure. The boiler begins to suck inward, pulling at every connection, every seal, every possible opening with force that can bend steel plate if it's strong enough. In a properly designed system, this isn't a problem. Check valves. Those one-way gates installed in every feed line prevent backflow. They're supposed to seal tight the moment pressure reverses, stopping any water from being pulled backward into the boiler. But check valves fail. The one on boiler number 3 failed slowly, quietly, over the course of months. A crack in the valve plate, a piece of scale caught in the seat, a spring that lost its tension. Small defects that didn't matter when the boiler was running normally, when pressure pushed forward and kept everything moving in the right direction. But now the boiler was cold, the vacuum was pulling backward, and the check valve was open just enough. The reservoir sat 30 feet above the boiler room floor, gravity-fed, always full. The feed pipe ran down through the brick wall, across the ceiling, and connected to the boiler through that supposedly disconnected line. Except it wasn't fully disconnected. The union joint was open, yes, but only at the boiler end. The pipe still ran back to the reservoir, still connected at the upper end, still full of water all the way up. When the vacuum formed inside the cooling boiler, it didn't pull air. It pulled water. Up through the disconnected joint, across the gap, into the boiler shell. A siphon in reverse, powered not by gravity, but by negative pressure. The water came slowly because the opening was small and the vacuum was weak, just a few pounds per square inch below atmospheric. But it came steadily, inch by inch, night after night. And every time the boiler cooled further, every time condensation formed on the cold inner surfaces, the vacuum grew stronger. The boiler wasn't filling itself, it was breathing in. It happens on the 8th night. Beckett is checking the main boilers in the adjacent room when he hears it, a sound like distant thunder, but metallic, a deep groan that resonates through the brick walls. He runs. The door to boiler number 3's section is already open. Porter is standing in the doorway, lantern raised, face pale. The sound comes again, louder this time. The boiler shell itself, flexing under stress. Beckett pushes past him. The sight glass shows water 3/4 full now, higher than it's ever been. But that's not what makes his blood run cold. The boiler is moving. Not much, just a slight tremor, a vibration transmitted through the mounting brackets into the brick floor. But it's enough. The steel shell is under stress, the vacuum inside pulling inward against atmospheric pressure outside, and the metal is protesting. A pipe overhead, one of the condensate lines, suddenly flexes with a sharp crack. Water sprays from a joint that held solid for 4 years. Porter shouts something, but Beckett can't hear it over the hiss of escaping steam from the running boilers next door. The vacuum is growing. He can feel it in the way the air moves, the way the disconnected feed pipe trembles on its support brackets. If it gets strong enough, if the condensation continues and the temperature drops further, the boiler shell could implode. 12 feet of riveted steel plate, collapsing inward under 14 pounds per square inch of atmospheric pressure. 200 tons of force trying to crush the vessel like a tin can. Beckett grabs a wrench from the tool bench and runs to the blowdown valve. His hands shake as he unlocks the chain, but his mind is clear. He needs to equalize the pressure, let air into the boiler, break the vacuum before the shell fails. Porter is shouting at him to stop, to get out, to let the foreman handle it. Beckett ignores him. He throws the valve open. The sound is like a gunshot. Air rushes into the boiler through the bottom drain, screaming through the valve with enough force to rattle the pipe. The vacuum breaks instantly, equalizes in 3 seconds. The groaning stops. The vibration ceases. Water begins pouring from the blowdown valve, flooding across the brick floor, running toward the drain grates in dark rivers. Beckett doesn't close the valve. He lets it drain completely, every gallon, until there's nothing left but air and the echo of moving water. His hands are shaking. Porter is sitting on the floor with his back against the wall, breathing hard. The boiler is silent now, empty, cold. But they both know what almost happened. The engineers arrive the next morning, 2 men from the regional office with leather cases and measuring tools and an air of professional skepticism. Garrick briefs them in clipped sentences, refusing to meet their eyes. They listen without comment, then ask to be left alone with the boiler. They work for 6 hours. First, they map every pipe, every connection, every valve in the system. They sketch diagrams, take measurements, test each component individually. One of them, a thin man named Caldwell with ink-stained fingers, spends an hour just examining the check valve assembly, turning it over in his hands, holding it up to the light. He finds the crack. It's barely visible, a hairline fracture in the bronze plate, hidden under a layer of scale. But it's enough. Under normal operating pressure, the valve sealed fine. Under vacuum, it pulled open just enough to allow backflow. The other engineer, Brennan, traces the feed line back to the reservoir. He measures the elevation difference, 31 feet. He calculates the potential siphon force. He examines the disconnected union joint and finds witness marks on the internal surface, evidence of water flowing through the gap at high velocity. By afternoon, they have the full picture. The boiler, when shut down, cooled rapidly due to the cold November air in the unheated section of the building. As the steam condensed, the internal pressure dropped to nearly 0, about 13 pounds per square inch below atmospheric. That vacuum, combined with the elevation of the reservoir and the failed check valve, created a powerful siphon effect. Water was pulled backward through the feed line, through the disconnected joint, and into the boiler shell at a rate of approximately 2 gallons per hour. The condensation inside the boiler itself contributed more water, moisture drawn from the air through the various unsealed openings, condensing on the cold metal surfaces and dripping down to collect at the bottom. The system was, in essence, a massive atmospheric engine running in reverse. The boiler had become a low-pressure chamber, and nature was trying to equalize it using any available fluid. Caldwell writes it all in his report, diagrams included. Brennan adds recommendations. Replace the check valve, install a proper vacuum breaker, ensure all disconnected lines are fully isolated with blind flanges, monitor condensation rates in cold weather shutdowns. Simple fixes, obvious fixes in retrospect. But it took 8 nights of mystery and near disaster to see what should have been visible from the start. Chapter 7, Reflection. The boiler runs again 3 weeks later after the repairs are complete and the inspectors sign off. It operates normally, heats water, generates steam, powers the mill turbines without incident. Within a month, the whole affair is nearly forgotten. But Thomas Becket doesn't forget. Some nights, when he's checking the running boilers during the quiet hours, he thinks about those 8 days, about the water rising in the sight glass with no source, about the sound of steel groaning under vacuum stress, about how close they came to a catastrophic failure without understanding what they were facing. The industrial age gave us machines of incredible power, engines that could drive factories, locomotives that could cross continents, boilers that could convert water into force. But we built them faster than we understood them. We scaled them larger than our experience could safely guide. The men who worked these machines, who fired them, maintained them, trusted their lives to them, learned through disaster. Every explosion taught a lesson about pressure limits. Every failure revealed a weakness in design. Every mystery, once solved, added another line to the growing body of knowledge that we now call engineering. But in those early decades, there were no textbooks for this. No experts to call. Just workers with wrenches and foremen with instinct and machines that sometimes did things machines weren't supposed to do. Boiler number 3 didn't fill itself through magic or malice. It filled because physics doesn't negotiate, because vacuum is as real a force as pressure, because a small defect in a check valve combined with specific conditions can create effects that seem impossible until you understand them. The machine wasn't alive, it wasn't thinking, but it was acting, responding to forces and conditions in ways its builders never anticipated, never planned for, never even imagined. And that, more than the mystery itself, is what haunted Becket in the years that followed. Not that the boiler filled itself, but that it could. That somewhere in every machine, no matter how well designed, no matter how thoroughly inspected, there exist possibilities that only reveal themselves in darkness, in silence, in the cold hours when the steam dies and the metal begins to speak in languages we don't yet understand. The industrial age was built by men who learned to listen to those languages, who paid attention when machines did the impossible, who understood that steel and steam and pressure were forces powerful enough to reshape the world, but also dangerous enough to destroy anyone who forgot that power demands respect. Boiler number 3 still stands, preserved now in a museum in Pennsylvania. The crack in its check valve is visible through a glass case, labeled with a small brass plaque that tells the story in 3 sentences. But the real story, the one about 8 nights in November when experienced men stood in the darkness and watched water appear from nowhere, that story lives in the archives, in Caldwell's engineering report, in Garrick's logbook entries, in the newspaper article that treated it as a joke, and in the memories of the night crew who learned, through mystery and fear and near disaster, that the machines we build are never fully tamed. They're only temporarily understood.